How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at phase diagrams. So objectives: identify important features of phase diagrams, including triple points, critical point, phase equilibrium boundaries, and use them to predict what phases are present under varying conditions and what phase changes will occur with the change in various conditions. It means like, hey, I have a gas and I increase the pressure, what will happen? All right, so let's talk about phase equilibrium. We know that we can have phase equilibriums between solids and liquids, liquids and gas, and we can even have it between all three, right? So here on the left, we have solid liquid equilibrium. You can see that there's a solid particle here, definite shape, definite volume, but then we got liquid, right? We could also have gas and liquid equilibrium, as well as, hey, here's a mixture of all three. Phase diagrams are going to show under which conditions of pressure and temperature that these equilibrium exist. So this is what they look like a little bit. So on the blue region, this is where the solid phase exists. So if you're like, hey, at this pressure and this temperature, what phase exists? Well, hey, it's in the solid phase. And the way I remember, which is what, just think, hey, at low temperatures and high pressure, what phase would you expect? Low temperature, high pressure. All right, they're going to be really cold and going to be pushed together. I would expect a solid. For the pink region, that's where the liquid phase exists. The green is where the gas phase exists. And again, I think it through if I can't remember which is what. All right, over here, I got really high temperature and really low pressure. What phase would I expect? I would expect a gas, all right? So this purple line right here is showing the equilibrium between the solid and the gas. So that's sublimation and deposition, right? If we go from a solid to a gas, that's sublimation, gas to a solid, deposition. Right, that pink line over here is showing the equilibrium between the solid and the liquid. So that's melting and freezing. And then the green line is showing the equilibrium between the liquid and the gas. So we got vaporization and condensation, right? The point C that's over here, right here, is the critical point. So it is where the critical temperature is and where the critical pressure for that substance is. That if you go any higher with pressure or higher with temperature, you result in a supercritical fluid where the liquid and the gas phases are indistinguishable. So that whole region over there, that's where we have the supercritical fluid state. And then point T, if you see point T on here, that is what we call the triple point, because it is where all three lines intersect, and it is where all three phases are in equilibrium with each other. So you'll have solids in equilibrium with liquids, liquids in equilibrium with gas, all together. All right, so the slope of that melting and freezing line. So if you see here, this one leans to the right, this one leans to the left. What kind of impact is that going to have on things? Well, if it has a positive slope, meaning it leans to the right, if you're in the liquid phase, and you increase the pressure, you can cause freezing. So basically, if I'm right here and I'm in the liquid phase and I increase my pressure, I'm going to move up and I'm going to end up in the solid phase. For a negative slope, it's a little different. You know, if you're in the solid phase and you increase the pressure, you can cause it to melt. All right, so most substances have a positive slope. Like more often than not, that solid phase is more compact. So increasing the pressure means you want to end up more compact and you would be in the solid phase. But water is one of those substances where it has a negative slope, because we know ice expands when it freezes. So if you apply pressure to that solid, what's going to be a more dense arrangement is going to end up being a liquid phase. All right, so these things are not usually color-coded or labeled, right? So this one's real nice for looking at and learning about, but most of the time you're going to see this one. So things you need to be able to do. You need to be able to identify where each phase is, where the triple point is, where the critical point is, and determine what would happen if you started at X and increased or decreased the temperature or the pressure. So let's take a couple looks. All right, which point corresponds to the critical point? Right, based on this diagram, it's going to be point D, right? So point D over here is the critical point. Which one's the triple point? So triple means three, where do all those three things intersect? At point B. You know, where would a solid and a gas be found in equilibrium? All right, so I need to remember that this is solid, this is liquid, this is gas. So we're looking for an equilibrium between solid and a gas. Hey, that's going to be point A. All right, where are three phases in equilibrium? I know this one. That's the triple point. That's point B. And where do we find solid and liquid in equilibrium? All right, well, I already know that my solid is over here, my liquid's there, so I'm looking for somewhere on this line. That would be point C. Some more examples. If I was, what phase is present at X? Oh, well, hold on, I got to remember. We got solid, liquid, gas. So at point X, we got a solid. What would happen if you increase the pressure? Well, let's see. I'm at X and I increase the pressure. It could melt. It could turn into a liquid. What would happen if you increase the temperature? All right, well, increasing the temperature, I'm going this way. It would also melt. All right, what if I was at X in this diagram? All right, what would happen if I increased the pressure? Let's see, nothing really. It would stay a solid. It's in the solid state. It's going to stay in the solid state. What would happen if we increase the temperature? Temperature moves left to right. Increasing that, it could melt. And if I kept increasing it, I could even vaporize it. But let's just say the first immediate thing is going to be to melt. All right, what phase is present at point X? Again, we got solid, liquid, gas. So at X, we got a liquid. What would happen if I increase the pressure? If I'm at X and I increase the pressure, nothing would happen. All right, I'm going to stay in the liquid state. What would happen if you increase the temperature? All right, well, if I increase the temperature, oh, hey, look at that. It could go into the gas phase. It could vaporize. All right, summarize. Can you identify important features of phase diagrams, meaning triple point, critical point, phase equilibrium boundaries, and use them to predict what phases are present under varying conditions and what changes will occur with change in various conditions? I hope so. Hope you found it helpful. I'll see you in class. Get back.